Now we're going to look at section 4.4 about contingency tables. A contingency table, or a two-way frequency table, is a table in which frequencies correspond to two variables. One variable is used to categorize rows, called the row variable, and a second variable is used to categorize columns, the column variable. Each box inside the table is called a cell. Here's an example of a contingency table. A U.S. News and World Report article about polls stated, "On sensitive issues, people tend to give acceptable rather than honest responses. Their answers may depend on the gender or race of the interviewer." To support that claim, data were provided for an Eagleton Institute poll in which surveyed men were asked if they agreed with this statement. Abortion is a private matter that should be left to the woman to decide without government intervention. The contingency table below summarizes the results of the poll. So the information we have is broken up by the subjects and whether they agreed or disagreed with the statement, and also by the gender of the interviewer, whether the interviewer was a man or a woman. So the contingency table has two variables, and those are the same as what's in the rows and the columns. So one variable is the response of the man who was being interviewed. The other variable is the gender of the interviewer. So for each one we have two values for the variable. So gender of interviewer, we have either man or woman, and for the response to the question we have either agree or disagree. Those are our values. So for example, this 560 here is the number of men who agreed with the statement when they were interviewed by a man. The 308 is the number of men who agreed with the statement who were interviewed by a woman. So first we can construct contingency tables from data that's already been summarized. Sometimes we just get a list of numbers of how many subjects were in each different combination of categories. So if we have a summary like that, then what we need to do is identify what the two variables are, and then identify the possible values for each one of those variables. Once we've identified those variable values, we'll use those as our row headers and our column headers in the table. And then finally we just fill in the cells of the table with the numbers from the data summary that we had. So here's an example. In an experiment to test the effectiveness on echinacea on preventing the common cold, subjects were given either a 20% echinacea extract, a 60% echinacea extract, or a placebo. Subjects were then observed and identified as becoming infected with a cold or not becoming infected. Among subjects given the 20% extract, 48 became infected while 4 did not. Among subjects given the 60% extract, 42 became infected while 10 did not, and among those given a placebo, 88 became infected while 15 did not. Create a contingency table showing the results of this experiment. As you can see, it's kind of difficult to tell the results when they're listed out in a paragraph form like this. Most people find it a little bit easier to interpret results like this if they're given in a table. So that's where our contingency tables come from. So the first thing we want to do is identify our variables and then identify the possible values for each variable. So our two variables are, first of all, the treatment given, whether it was some form of an echinacea extract or a placebo. The possible values for this are either a 20% echinacea extract, a 60% extract, or a placebo. Then our second variable is whether the subjects became infected with a cold or not. So the two possible values for that are either they became infected or they didn't become infected. Okay, so to construct our table, we've got our variables and the values, and we can choose either variable as the row variable, and then the other one will just be the column variable. So if we choose the infection status as the row variable, then our table is going to look like this. So for our row headers, we've got the two values for that variable, so infected and non-infected. For our column headers, we've got the three values for the treatment, so either the 20% extract, the 60% extract, or the placebo. So now we've got our headers done, and now we just need to fill in the cells of the table. So here's the information that we were given with the actual numbers. So we're just going to put these in the appropriate places in the table. Here's the table that we started with. So we can just go through this, and here we've got the subjects that were given the 20% extract, so those numbers are going to go in this column. So 48 became infected, 4 didn't. So we're going to have a 48 here and a 4 here. And then we go over to the 60% extract and we get 42 and 10, and for the placebo we've got 88 and 15. So here's the table with all the numbers in it. If we want to give ourselves a little bit of extra information, then we can do row totals and column totals as well. Now the other thing that we might need to do is to construct a contingency table from raw data. This is a little bit harder, especially if the data set is very large. So if the data set is pretty small, then we can do this by hand, just by counting up how many observations are in each combination of categories. Otherwise, we want to use software, either some type of statistical software. We're going to use StatCrunch in an example. Or if you have the information in Microsoft Excel, you can do pivot tables if you know how to do that. So we still have to start out by identifying the two variables and the values for each one. And then again, we use those variable values as row and column headers. Here's the example we're going to look at. A study of 4th, 5th, and 6th graders in Michigan looked at which factors children consider most important in determining popularity. The children filled out a questionnaire and were asked to rank 4 factors: grades, looks, sports, and money, in order of importance in determining popularity. So we're going to use StatCrunch to create a contingency table for the two variables from this study, grade level and the factor ranked first for popularity. So this data set is in StatCrunch already, so I've signed into StatCrunch. This data set is in our class group, so if you'd like to follow along, you can go to my StatCrunch and log in and go to our class group. So I'm going to our class group. So I'm just clicking on the thumbnail. That takes me to the group, and notice it has a data sets preview down here, but if we want to see all the data sets for our group, we can just click on the 19 data sets up here. Just click on the word data sets, and that will show us the complete list of data sets for our group. And I'm going to scroll down here to the Popular Kids study, and this has a more complete description of the subjects and the different questions that were on the questionnaire that the kids filled out. So let's just look at the data set. So we've got all these demographics for the kids, whether they're in an urban or a rural setting, which elementary school they were from, their goals in terms of whether they wanted to be good at sports or popular or get good grades. And here is one of the variables we're interested in, which factor they ranked first as being more important for popularity: grades, sports, looks, or money. So we want to do a contingency table that uses that variable versus what grade the child was in, so grade 4, 5, or 6. In order to do that, we're going to press the Stat button here. We want to go to Tables, and we're doing a contingency table. And this one we're using raw data, so we'll tell it with data. Okay, a dialog box comes up and it's going to ask us which variable we want to use as the row variable and which one as the column variable. So let's just pick grade as our row variable. It really doesn't matter. We could pick either one as our row variable and then the other one as the column variable. Our second variable was which factor the child ranked first, so we'll choose that one. Now if we wanted to filter our data before we did the contingency table, or if we wanted to group it by some other factors, we could use these two tools, but we're not going to do that here. So I'm going to click on Next at the bottom. If we wanted relative frequencies in addition to our regular frequencies, we could click here where it says percent of total. That would give us a relative frequency for each cell in the table. Or if we wanted to know what percent a certain cell had in its own row, we could click row percent. If we wanted to know a percent in each column, then we could click column percent. But right now we're just looking for frequencies, so we're not going to check any of those boxes. And this procedure will automatically do a hypothesis test unless you tell it not to. So let's uncheck this box because we're not doing hypothesis testing yet. So now down at the bottom you can click on Calculate. Depending on which version of StatCrunch you're using, this may say Compute instead of Calculate. And here we have our contingency table. Notice that it automatically categorized our variables. It gave us all the different values that came up for grade and for factor ranked first. Now if we want to save this contingency table, we can either save it to our StatCrunch account, you can copy it and paste it into a document, or you can print it. So what I'm going to do is save it to my StatCrunch account. So here it says export to my results. That's what I want to do. And I'm going to name this so that I know where it came from. So I'm naming it Popular Kids Contingency Table. I don't want to share with everyone in the StatCrunch world, but I do want to share it with our group. So under Share with Groups right here, I'm highlighting ACC Stats Fall 14. And if I want to write some notes to myself so that I know more about this, I could put that in here. Tags are to make it easier to search for this. So now I'm going to click on Export at the bottom. And that saved it to my StatCrunch account, and the results should show up in our class group. So if we go back to our class group that we had pulled up, now this has the data sets. I want to go back to the actual group. So I'm just going to go over here and click on the thumbnail again. And notice now up here it says 19 data sets, and it also says 1 result. So if I want to look at all the results for our class, I would click there, and we only have one right now, which is this table. If I want to see the table closer up, I can just click on it or click on the title, and it brings it up. Now one other thing we can see by looking at this table is we can get an idea of how the two variables are related to each other. So we have the children split out by what grade they're in, and then we have how many in each grade chose each one of these factors as being the most important for popularity. And notice that money was the factor that was picked the least in any grade. But as far as which other ones were picked, it's different depending on which grade they were in. For example, for the 4th graders, the factor they picked the most was looks. Whereas for the 5th grader, the factor they picked the most was sports. And if we look through the columns here, notice that for grades, the grade level that picked this one the most times was the 5th graders. For looks, the grade that picked this one the most times was the 6th graders. And for sports, the one that picked this one the most was also the 6th graders. So we can see there is a difference between the 4th, 5th, and 6th graders as to which one of these factors they might think is the most important for popularity.